week's professional development seminar. My name is Tim Kirk. I'm the facilities manager for the College of Engineering here. I want to welcome our guest for our speaker today is Stan Portola, sorry. So he was born here in Alaska. He has a Bachelor of Science in Petroleum Engineering from UAF and a Master's in Arctic Engineering from UAA. He's worked in the oil and gas industry for the last 23 years in both the Cook Inlet and the North Slope. And with that, I will pass it over to Stan.
Thanks, Tim. All right, welcome everybody. Today's topic, exploration and grassroots drilling. So I kind of go over this high-level discussion of what my experience last 23 years working both Cook and North Slope here in Alaska. So as mentioned, my bachelor's from UAF, class of 2002, Master of Arctic Engineering 2005. Started my career, first job out of college, while I was in grad school, was the Bureau of Land Management. So both worked in PRA as National Petroleum Reserve Alaska and Cook Inlet. Then I moved on to a job as a drilling completion engineer with Chevron, and working also North Slope and Cook Inlet. Then when Chevron got bought out, I moved on to Link Energy, drilling completion engineer there, working the Umiat North Slope project and also the underground coal gasification project in Cook Inlet. Left there and went on to Hilcorp as an operations engineer there for 7 years, working 2 years in the Kenai team and then 5 years in the North Slope team, working Milling Point and Endicott and North Slope, North Star. Left Hilcorp during the pandemic and started my own company, consulting company, Arctic Horizons. Did some various kind of consulting work here in Alaska. Worked on the development of the DeLorean rig. It's a small kind of remote mining, remote exploration rig that Alaska Drilling Completions utilizes, and did some recycling of oil field plastics from the different threat detectors. Eventually got a job with the state Department of Environmental Conservation in spill response. So I did some spill response engineering, mostly involved with tanks and pipeline inspections across the state. And then currently, for the last 2+ years, been working for Glacier Oil and Gas, working both North Slope and Cook Inlet, North Slope field Badami, the Cook field West MacArthur, and the Beadle Shoal unit. So on a day-to-day basis, I do all kinds of different work across the board, not just drilling, but we'll kind of focus on some of that here today. So today's topics, we're going to kind of go over basics, starting with mapping, oil and gas basins, and then oil seeps. Then talk about leasing and unitizations, units, talk about seismic and geology. Then we're going to go into well construction, how you design oil and gas wells, talk about the tubulars involved, what well control involved, what it looks like, and then kind of wrap up on fracture stimulation. It's not the only way you can complete oil and gas well, but it's one of the kind of more common methods now, especially with shale plays. But we'll talk about kind of what goes on here in Alaska with a lot of our wells on the North Slope that are fracked. Also, some wells in Cook Inlet are also fracture stimulated, but we'll talk about that as we go along. So with basic mapping, a good place to start. You want to look at different things like ArcGIS, what kind of AutoCAD you have available to you to help you map. Visual Oil and Gas, some of the maps they have there are really good as far as for all the information you want, North Slope and Cook Inlet. I use Google Earth all day long. It's kind of a common tool I use to do a lot of the mapping. Alaska Mapper is one of the state's tools they have. And you can utilize that for a bunch of different state information about the different areas. DGGS is also a state agency. That's the Geological and Geophysical Services. They do a lot of the geology work across the state. And then also the Bureau of Land Management, they have a lot of the federal stuff. And also, as the land conveyances goes from federal to state, the Bureau of Land Management is involved. So I did include some links on here. So on this presentation, I've got my links to all this publicly available information out there. That's kind of the best way to kind of go forward with utilizing this. So one example from the Division Oil and Gas, this is their, they update this every once in a while, their North Slope activity map. And this is just a map of all of the different oil and gas units on North Slope and the different exploration plays and different activity that's gone on. I think this one was like early 2025 when this one came out. So they're talking about different stuff that was going on just over a year ago. So I'm not going to go into a lot of detail. Some of the stuff I worked, so the Badami field, the B133A well is one of the wells they helped work on, bring online when they were drilling that. And, yeah, more than doubled their production at Badami. That was a really good, strong well. We'll make about, there are 700 barrels a day currently, and we're looking at future potential operations there. And then another thing that, Savant, Alaska, which is one of the subsidiaries of Glacier Oil and Gas, we have leases down here in the Grail unit. So that's about 30 miles south of Badami. Then obviously there's the Prudhoe Bay unit, Parik, Alpine, what Santos is working on currently, the Pika unit, and then out here in NPRA, the Moose's Tooth unit, and then what's commonly referred to as Willow, that's the Bear's Tooth unit. So that's where all the Willow activity is at. And then there's other operators like Great Bear doing work down here in the Toledo Alcade area. So, and currently Hillcorp's drilling out here at Point Thompson. There's lots of drilling going on at Prudhoe Bay and also at Kaparik and Milne Point as well. We talked about Tundra, and actually this just changed actually in the last few months. So I think it was in 2004, the state of Alaska designated areas for Tundra opening, the western coastal area, the eastern, the lower foothills and the upper foothills.
The old questions to the end, or can I ask?
You-
How about hopping back a slide? I was
Sure.
curious, who's present leaseholder of Point Thompson? You said, Hillcorp's.
So leaseholders is different than operators.
Mhm.
So Exxon and Hillcorp are both leaseholders. Hillcorp is the operator.
Oh.
Yeah, so
And
Exxon,
Exxon did the early development.
correct, yes, they were, I think they still have the majority percentage of the field. I think they're around 2/3, but Hillcorp is the operator. So Hillcorp does the operations, but Exxon and Hillcorp share in the production. Yeah. So, yeah, and that's one thing too, is that you say like, well, who's the operator? So Prudhoe Bay, Hillcorp's the operator, but actually ConocoPhillips and Exxon own the larger shares of that unit. Similar things with Kaparik, with Alpine. I think Alpine is mostly all ConocoPhillips, but different units. You have to look to say who owns the subsurface, working interest, and then who is the operator. And right now, Hillcorp is the dominant operator on the North Slope for most of the units. So what I was saying, so we're just recently the state of Alaska DNR pretty much combined the lower and upper foothills into one unit. So actually they have that on their website where this area is opened up, and basically the requirements are at 1 foot down, you need the tundra to be at -5°C, and you need at least 6 inches of snow cover on the western and eastern coastal plain areas. And then in the foothills, you need at least 9 inches of snow and -5°C at a foot down in the ground. So they have different monitoring areas where they monitor that, and then they make the determination whether or not to open the different areas. They also work with the operators when they're building snow roads or ice roads to open those up potentially earlier if required. But that's been opened up. And then NPRA has a totally separate tundra opening thing that they do in NPRA for on the federal side. Quick example of some newer units, the leases. So Armstrong, in combination with Apache and Santos, we're drilling wells out here just south of Badami. The most recent well they drilled was the King Street one, and then it's not on this map, but the King Sockeye 2, and they've disclosed they made a discovery on that. So more to come on that one, but this is the licensed areas, their lease blocks that they currently have. And then the same thing over here, this is the lease block that between Great Bear and I think 88 Energy in these areas, they have these different leases. So Pantheon, Great Bear Pantheon is the operator down here that's been drilling wells just off the Hall Road north of Franklin Bluffs. 88 Energy is the other operators looking to do stuff in the Tulik unit. But there's lots of constantly dynamics changing between who's doing that. This quick map shows you if you want to go to Alaska Clean Seas, they have lots of maps of different how they would handle spill response. This is one example up near. This is at Badami, showing how you would have if you had a spill in this general area, how you would protect basically your water resources and your tundra resources. So in their maps, they have these different maps for the different areas all across the North Slope and how they would respond to it. It's called their technical manual. So if you wanted to look into spill response, something with how you can handle looking ahead of time and be better planned, especially if you're going to be able to put out boom and how you're going to protect different water resources. If you had some spill out here and you want to protect it, they have different prescribed methods of how they would handle that. So Alaska Clean Sea is one of spill response operators up the North Slope. So this map this goes into how they talk. The PS means priority protection sites. So the protection sites that you're going to go through and how you're going to handle it. And they just talk about the different elevations and tundra and all the different things of what you're going to be dealing with logistically. Another EIS map, ESI mapping. This shows another thing about the different wildlife and other things that might be in the area. So being cognizant on the North Slope, all the wildlife and the seasonal wildlife and the long-term wildlife. So it's just another area to look at for additional information if you're trying to plan a project or if you're trying to make sure if you have what resources could be threatened. Now we're going to talk about basins, so oil and gas basins. So these are effectively, think of it as a depression in the ground where a lot of rock was deposited, and this is where generally where oil and gas basins can start from. So this is an example of on the North Slope. This is called the Colville Basin. So this is where a lot of all the oil fields are mostly based on. Is all here in the Colville Basin. Offshore, you have what's called the Beaufort Basin and then the Chukchi Basin. Other two areas prolifically where there's been a lot of oil and gas discovered. And all across Alaska, you have the Cook Inlet Basin, you have the Gulf of Alaska Basin, and other various basins all across where different ages of rock and different deposits as far as how oil and gas may have been generated and where you're going to be wanting to look for potentially how hydrocarbons could be eventually be deposited in those areas. So a quick example, Lower 48. If you might be more familiar with like the Permian Basin. So out here you have what's called the Wolf Camps, Rayberry, all these different rock formations that are within the Permian Basin, which is western Texas, eastern New Mexico. That's the prolific Permian Basin. You've got the Denver Basin up in North Dakota. You have the Bakken. Over here, the Utica and the Marcellus over in Pennsylvania, Ohio area. So just some different areas of different basins if you hear those names brought up. And this one was another colorful map that I found through map makers in an old Petroleum News article. This one just a little more colorful and talks about the different basins. To show that just map to get an idea as far as what's going on. Right now, most of the oil and gas operations are always based on the Cook Inlet and the North Slope, the Colville Basin. Hillcorp, I think, is doing some stuff here in the Yukon Flats. And there has been some recent drilling in the last 10, 15 years in the Nana Basin, and also the Copper River Basin. But right now, historically, the Katala field was down here in the Gulf of Alaska Basin. And then there's also, as part of the Cook Inlet Basin over at Niskin Peninsula. We'll talk more about that in a little bit. So just some other updated, these ones I highlighted, these are the ones where there's a significant amount of oil and gas wells that have been drilled in Alaska since the 1900s. In these various basins. So the majority of all the oil and gas wells been drilled since 1900 to today are found in these basins. So talking about oil seeps, and this is kind of what led people to, go question.
Just real quickly, when it led to the other basins, how do they know the basins are there?
Basic geology work. You come out and you look.
Surface geology?
You start with surface geology, yes. And then you make a determination with either seismic or drilling to then determine.
Okay, but no drilling permanent basins that aren't drilled.
Because you had everything was mapped to basins, even the ones drilled
Correct.
aren't shown.
Yes, most of that is probably through seismic technology.
Okay, that's fine.
And doing subsurface analysis through earthquakes and other things you can use to kind of analyze that. Good question. So how most oil and gas got discovered in Alaska is through oil seeps. So I've listed out various oil seeps that are kind of the more prolific ones in Alaska. And the first oil wells were drilled in the Niskin Peninsula in the year 1900. Niskin Peninsula is 60 miles due west of Homer. And the start of all the oil and gas, discoveries of where they wanted to go start drilling, started with, the Russian immigration as far as coming in, and when they were going for the fur seal trade, and they started noticing this, and that got back to other people and say, oh, there's oil seeps up here in Alaska. So Kewali Bay, this is over on the Alaska Peninsula. The Niskin Peninsula was another prolific one. Over here at Katala, Yakataga, and Yakutat and the some more Samovar Hills. And then the ones up on the North Slope at Skull Cliff, Cape Simpson, which was one that the natives were actually using the oil at those seeps. It's about 55 miles southeast of Barrow. The whalers, when they came up there in the mid 1800s, they said, "Hey, where are you guys getting that stuff from?" And they go, "It's over here." And they showed them these, where these oil seeps were coming to surface, and you could actually go, cut out a block of it and go put it and burn it and use it for various different reasons. So that's kind of what led to a lot of the initial exploration was based off of where the oil seeps were coming from. So this is an example of some of the plug and abandonment work I did up at Cape Simpson. This is the Simpson 26 core test well. This is Simpson 30A and Simpson 30. These were interesting things to deal with. Luckily, I dealt with those, the plugging those in the wintertime. But the seeps are still not fully frozen as they discovered in the middle of winter. But since the first plug and abandonment work started in 2006 in this area, and then the Bureau of Land Management went and did additional plug and abandonment work in like the 2010s. They completed the actual work. Now the seeps there are still today, but yeah, and then this is just showing like there was a whaling disaster in 1871 where a bunch of whalers got stuck in the sea ice and they came on shore, and but it all started with what's his name? Thomas Royce was an American. They came up there in the summer of 1848, and he was the first one to kind of actually hear about the oil seeps. Well, this because they were the first. He was the first one to go up there, actually start going for the bowhead whales up. That was a Westerner at that time. So news got around, that there was oil up there, and eventually, that's what kind of led to some of the exploration. So if you look at, really where this got hot and heavy up in, on the North Slope in the 1910s, 1920s, a lot of reports were put together out on the point potential of at that time put together by Warren G. Harding, Executive Order 3797, February 27. He created what was called the National Petroleum Reserve number 4. There's 3 petroleum reserves down in the lower 48, I think 2 in California, 1 in Wyoming. Teapot Dome is one of those. I think that's NPR3. And they sent geologic parties up here to determine, based off of just surface geology, what the petroleum potential was for the North Slope. So there's lots of different reports you can go out there to find different information on this. They said the first big one was this one, petroleum in Alaska, 1921. This talked pretty much exclusively about what was going on up here and what led to the Warren G. Harding designating this a petroleum reserve. So some of the work I got involved with was the legacy wells, what they call legacy wells. So these are all the wells that were effectively orphaned by the Navy and the USGS. Started drilling in 1944 up through 1981. There was 136 total wells, and so I did the first co-author with Rob Rumbaugh in 2004 on the first report. They had an updated report in 2013. Since then, they pretty much updated every 5 years. They have little interim reports, and many of the wells have been plugged and abandoned since then. So they've mostly been dealing with wells that were either leaking hydrocarbons, oil or gas, or were being threatened by coastal erosion. So that's interesting information on those 136. Majority of those wells were actually just bore holes drilled in the ground, no casing, no pipe left in there. They just drilled the hole, left the fluids in there, and it just froze over, just sitting there today. Those are just some of the core holes.
How deep were
The deepest ones, majority of the wells are all less than 10,000 feet, but the U.S.
we had the technology up there?
Correct, yes. The Navy in the 1940s, early 50s brought a big enough rig where they actually got down to over 10,000 feet.
Wow.
The USGS drilled, I think it's still the deepest well. I think it's Talagiap. It's over 20,000 feet. So, and that's way out in western part of NPRA. Thank you. Yep. So talking about oil and gas leasing. So this is a map of the Division Oil and Gas's North Slope area-wide sale for 2025. This line demarcates the foothills area versus the coastal plain area. And so this is all state land. So ANWR is over here to the east, and then NPRA over here to the west. The green are all leased areas. The other numbered areas were all available blocks in that lease sale. So the state kind of, chooses relative sizes for what they believe would be the areas where there's the more high, how they're going to just choose to do that. Basically, to say big chunks of land in sections and townships, and they come up with these. And And then based off of how much the land is bid, you bid on it, and then you pay rentals on it. And then to kind of hold on to the leases, you form into a unit. But then when you have a unit, then you have to make certain commitments as far as for exploration and development. So this is kind of a more updated lease map, and just showing you how they differentiate between all the different lease holders. There's lots of names you won't know or recognize. And some of the newer leases, like these ones over here, this one, this is, okay, those are pending leases. I don't see the name, but it was called, it's some small group out of Texas that kind of got these leases. But yeah, so it's, as you look at it, you'll see, you know, a dozen to 24 different groups that are bidding for the different leases up there. You see, you know, Glacier Oil and Gas, that's our stuff over here. But, you know, we have our subsidiary Savant, and you just have to know some of the nomenclature. Like for Hilcorp, they have Hilcorp Alaska, and then Hilcorp North Slope. Hilcorp North Slope is just the owner of Prudhoe Bay. They just recently, in the last few weeks, actually designate Hilcorp Alaska as the operator of Prudhoe Bay now. So Hilcorp Alaska is the only operator for Hilcorp, but Hilcorp North Slope is the subsurface owner of Prudhoe Bay. Hilcorp Alaska has all the subsurface of all other Hilcorps, oil and gas on North Slope and in Cook Inlet. So how you divvy up the land through sections, township, ranges. So basically a township is 6 sections. Each section is a mile by a mile. And then you have your different nomenclature of how you subdivide sections into the various different areas. And then you have all the various measurements, links and chains. This is carryover from older methods of how they used to measure things from, I think, the General Land Office and even before then. So, but this is a really good thing to understand how you can talk the nomenclature of sections, townships, and ranges and general land descriptions. So an acre is 43,560 square feet, which is, you know, yeah, 660 by 66 feet, or however you want to divvy up that section. Okay, so the existing North Slope oil and gas units we have. So we've got the major ones starting over here off the edge. You've got Point Thompson and Badami, Gray Owl, to the Tulip River, Talitha, and Alkaid. These are all effectively exploration units where there's no existing production facilities except at Alkaid. Great Bear does have one pad where they have a small production facility, not currently producing, but they have produced in the past. The bigger Prudhoe Bay, Duck Island, also called Endicott. The Liberty leases are out here just southeast of Endicott. Same formation out there as the Endicott, they're trying to get Liberty. North Star unit, the North Star Island, Milne Point, Nakaichuk, and Ugarik. Those are currently recently been taken over ownership by Hilcorp. You got Kaparik River. You have the Southern Maluvich unit, which is run by Finex, a small operator there. There's one single pad there called the Mustang pad. Pika, which is Santos, they're currently drilling that. They've got about, I think, 24 wells currently drilled for their development program. Probably half producers, half injectors. They're anticipated to be on production sometime this year. I've heard it could be as soon as March, but they're anticipating anywhere from 40,000 to 80,000 barrels a day when they come online from the Pika unit. And then the Colville River unit, also known as Alpine, that's over here on state land. And then next door to that is the Greater Moose's Tooth unit, or which used to be CD6 and CD7, but they call it Moose's Tooth 6 and 7. That's all piped over to Alpine. So this is the current production out of NPRA that ConocoPhillips runs. And then, like I mentioned before, Beartooth, this is the Willow unit. So they're currently actively doing exploration on that. They're hoping to have things down production by 2030 now. These are current timeline. Other ones, the Quokka and Horseshoe, these are other ones owned by Santos that they're hoping to eventually bring on to development. The Umiat unit still down here. This one, Umiat was drilled by the Navy starting in 1945. No sustained outside production has ever been had. The government did produce those wells for several years, pumping that and utilizing it for their own purposes. So just a quick little map of NPRA and the various native villages that are in there: Nuiqsut, Akasuk, Ukagvik, Wainwright, and then outside that, Point Lay and Point Hope. Very much a lot of lakes on the northern part of it, including a big one to Shekpuk Lake. And then as you go in further to the foothills, a lot less lakes. And then you have a bit of a divvying up of the native land, that's the native corporations, the regional corporations, the subsurface, and the village corporation surface, as they acquire land. So bit of a patchwork, but yeah, there's a bunch of different land ownership that goes on in NPRA. ANWR, also known as in the Bureau of Land Management's leasing, they call this the coastal plain. This is the 1002 area. So all this brown, this is all native land up here near Tektovik. And right now, I think the leases are still under lawsuit. They're talking about doing another lease sale, but more to come on that one. Very, very political. All right, talk some geology and seismic. So this is an example of seismic lines. So if you have, generic bottom hole seismic, you'll see these. There's lots of various ways of how you analyze it and make it, shape it, and look at it and tune it. And then basically this is overlaying with a person, call it geologist's interpretation of the various different, units and how they would do this. So it's kind of like a pseudoscience in one sense, because some people may see something different than others. And a lot of this is really helpful when you actually have offset well data. So this one has the Grizzly well drilled, I think that was by Conoco a couple of years ago, the Heavenly well, and then the Malguk well. These wells help you to then identify the actual geology you drilled through versus just using the seismic. And so basically you're looking here from east to west, the Schrader Bluff, also known as the West Sack Formation, depending on what part of North Slope you're at. This is where a lot of the heavy oil comes from. Hillcorp's been doing a lot of work at Milne Point with the Schrader Bluff. That's about Schrader Bluff at Prudhoe Bay. Oh, sure. Oh, okay. So question is, what makes up a unit? A unit is basically a bunch of leases that somebody's put together and said, we believe there's hydrocarbons under these leases, and we think there's the unit would be an area where it can kind of develop this with either one drill site or multiple drill sites, under that combined leasehold, and it can be various different formations. So you could set up a unit over these leases and drill and produce from the Schrader Bluff. You could generally, the Tulovac is a gas-bearing sand. The Nanushik is where Santos and all the original, a lot of the new drilling coming here, what's called the top sets. You could have production of the Torok and all these various formations coming up at different drill sites, but have it all come to either one or multiple production facilities, and that could all be in one unit or it could be in several units. So the Tulovac sand here, this is a sand that's been famous for blowouts, for gas blowouts. Drilling into it, going back to the early 90s at the Surf well. More recently, ConocoPhillips at CD1 had a blowout at the Tulovac sand. So this is generally a sand that's also been produced from, but it's been somewhat troublesome as far as when you've been drilling into it, and if you don't properly isolate it, it has been giving it had caused some various blowouts. As you go down, the Nanushik and the Torok have become more prolific, more production online with that. And then here, the Shublik and the Kingak are various shales that are part of the hydrocarbon system, where the hydrocarbons were generated and then somehow migrated, depending on the time scale of where they got to.
Why is the Tulovac more prone to blowouts?
It's part of it is just it's highly permeable, so the gas is able. So when you're drilling through it, the gas is more mobile, and if you don't have the proper drilling mud weight for a variety of reasons, the gas it can move fast. And so it's not in a tight rock, let's say. It's more of a good sandstone. And so I don't think it's much overpressure, but that's just part of the things that you have to worry about, your different drilling hazards and making sure that you're properly, when you're doing well construction. We'll kind of talk more about that with well control later in the presentation. So another example, this is the seismic from Liberty. So basement rock usually means metamorphics. You're usually not in hydrocarbons. Maybe in the future there'll be hydrocarbons in the metamorphic rocks. I don't know, but we generally don't drill into metamorphic rocks to look for oil at. So the Kayak is a shale. The Lisburn is a dolomite zone that limestone type formation that they produced from at Prudhoe Bay. And so this is just showing you various examples. Trying to understand all the squiggles and trying to figure out, what are these different faults that are here and the different pay zones. So these zones would be the pay zones. So zone 2, zone 3, zone 1. I believe these would be the Kekatuck formation, which is the same formation at Endicott. This is what they would be looking to produce from at Liberty. All right, so just real quick on this one. Yeah.
On your prior slide, don't go back.
Oh,
Those, before that one, the production areas can be quite deep or thick. Like right
Correct.
there, they ended, Grizzly ended right in the middle of the green. That is a whole production zone in there?
it all depends. It really depends on different formations, whether or not this is fully charged up. It's amalgamated or bulky.
Because the other ones are very finite ending on smaller zones, it seems like.
Correct. Some zones will pinch out like this. Other zones are more
Okay.
ubiquitous and big.
No.
And it really depends on where the hydrocarbons started from, where they migrated to, how they're going to stop. Because let's say if hydrocarbons are being generated down here in the King Gek up here, if that oil migrated through here, it's just going to keep on going. And then eventually you would think the most likely thing is that there would probably be oil here. If there was the reservoir, the timing, all those different factors kind of played in together.
Very complicated.
It is. It's very
On
complicated
the
and
street, if you're not into physics, you think there's just this reservoir you're tapping.
no.
This is fascinating.
No, it's much more complicated than people think, because when you drill into this, you're not just saying all this has oil. You may see only oil in a part of this. And the CV formation is not going to be just one big blocky sandstone. It's going to have silt, it's going to have clays, it could have breccias, it could have conglomerates. It's a bunch of things that are kind of, this is more like the CV, and this I will show later on, is more like a moment in time to say this formation was deposited under these circumstances, and that's what then you'll kind of.
So different geologic areas as well.
And different formations will be different more prolific and produce in different areas.
That's fascinating.
I just include this slide. This is just various seismic data. So they just show you the lines. So basically, most times when they're shooting seismic, you have these fiber-sized trucks that are sitting on these geophones, and they'll make lines across the ground. So they track where they went, they shoot the seismic into the ground, and they record the data. And basically, you use these different, what they call surveys. That's where that data comes from. So they have generally different names for it. These are, I think, all with the state of Alaska. These are the publicly available, but I think you have to pay for these. So I wouldn't suggest anybody paying $20,000 for a seismic survey unless you want to, play with that or whatnot. I don't know, but what good that would do you if you don't own these leases. But it's very interesting information, and you can get the public information about these to look at different stuff and know where they're going. Same thing applies for Cook Inlet. You have all these various surveys in the past that have been done for various reasons by sometimes by the companies themselves or by third parties trying to sell the data. But just to show you that this, and this is, I don't think it's all the same, but this is just the data the state in Alaska has available to sell for public release. And this was the list of all the different surveys. So this is the names of the surveys, the years, the size of the, how many gigabytes of data you're going to get. And, you would only know what to do with it if we're going to turn it into something useful. So basic geology, this is kind of the stuff I kind of like looking at to kind of really shape it to me. You say, we're talking the ages. So we know Jurassic Park. Okay, what is that? That's an age of the rocks. And so older rocks below that would be the Triassic, the Permian, Pennsylvanian, Mississippian. And generally here in Alaska, you get to pre-Mississippian, you're in a basement rock, you're in metamorphic stuff. So and then right here are the various prolific formations that we've drilled from, and produced from. So the Saddler-Roche Goop, this would be Prudhoe Bay. Lisburn would also be at Prudhoe Bay. This is a limestone that people have gone after, and talks about here the different fields where they produce from. So Endicott and Liberty would be from the Lisburn group, and also there's I think 5 pads at Prudhoe Bay that are called the Lisburn pads. They produce from the Lisburn group. Now, sometimes when you drill an oil well, you might go through here and have multiple different formations that are all prolific. Like when I dealt with at Milne Point, you had at the surface, you had the Ugnu, then the Schrader, then the Kaparic, and then the Sag River sandstone. All were there, but not every single oil well had all 4 of them. It all depends on the geology and where they're at the surface, or from the surface looking down, if they're prolific or not, if they have the hydrocarbon charge, if the zone can actually be produced from. But these are just some the ages and the different fields. And the petroleum system, so petroleum system is more like, where did this come from? So, Endicott, they got their oil from the Kayak Formation. Lisburn got it from the Kuna Shale. There's the Shublick Shale, the Kingak, and there's the Hugh Shale, Pebble Shale, Torak, and the Hugh Shale is a lot what I deal with at Badami. We leave like the Hugh Shale is right below our reservoir. So basically where your shales are generally determines where the hydrocarbon charge is coming from and the different ages of the rock. So a lot of the North Slope now is heavily into the Cretaceous. So a lot of what Santos is doing at the Pika unit, which is Nanushik, and even Conoco's getting into a lot, is Cretaceous age Nanushik formation. So this is another nice one. If you want to look at the ages and what chronostratigraphy, you can see the different ages and the different how they break it down. It gets very into speaking geology talk is basically what I have this one for. And then another example, this is from a USGS open file 95-236, talks about the geology in the Umiat area, the different stuff I've dealt with in the past. And here's a nice little breakdown from this website. I think you might have to go to a different website today to actually get this, but stratigraphy.org has all these different formations and discussions as far as the ages of the different rock. And this goes all the way back to 4.5 billion years. So the original, start of the Earth in the Hadean. So this is a cross section focusing on the Brookian formations. The Brookian is an age of rock, and this goes from west to east across the North Slope. And these are various wells that were drilled, the different density neutron logs that were drilled, the gamma and SP logs or gamma resistivity, and then various interpreted zones down there. So just basically kind of trying to determine, like, if I wanted to drill, so and this one doesn't go all that far over, but if I was going to drill, I think that, so meltwater. So this is over western part of Kaparik. So they drill down here. You would use this to say, okay, I think I'm going to go drill over to the west or the north or wherever, and hopefully get these same kind of formations. So this is kind of telling a story from a 2D perspective as far as where these different zones are at, where you can expect different shales, and you can see how some of these things, like geologically, have been deposited, some have been uplifted, some have been brought down. It all depends on how the rocks were put into place. So we'll talk about Badami geology. So this is some of the stuff we have locally that I deal with.
Question.
And so the Badami geology, like I said, we've got the huge shale here below Canning Formation, where a lot of our production comes from. So this says age equivalent of the nearby Badami field. I forgot which well this is. I think it's one of the Mickelson Bay wells. But this is just showing like this is the age of the Badami sandstones that we deal with at that field. But just a blown up, just closer version showing the different information and interpretations that these have. All right, so question, does one well produce from more than one system? Yes, so you can have a well and they call it commingling. So let's say we've done this at Badami. So we have the Killian sandstone and above that the Badami sandstones. And we actually have approval to commingle those together in one wellbore. There's a reason why you would and wouldn't do that, but generally it's more cost effective in certain times to drill one wellbore and produce from the different formations as opposed to having drilled two dedicated specific wellbores. Obviously it's going to be, if the wells cost the same, be twice the cost, but you'll get only the same amount of production. And it really depends on how the hydrocarbons mix together, their pressures, and generally most hydrocarbons, if they're the right densities, they'll mix together and you won't have any issues. But the pressures is usually the bigger thing that goes into it. But I'd say most wells in Alaska are usually dedicated to a single formation. Outside of a lot of gas wells and Cook Inlet, a lot of gas wells you'll just commingle multiple different sands, and they may not be the same age sands, but you can have a lot of different what we call perforations or holes in a single oil well. You can have thousands of them and trying to produce whatever's there. And I'll show you some kind of information on that in a little bit here. So overview of the Brookian sequence and plays. So just trying to show you just how the basic geology kind of the terminology here, what they call top sets. So sand prone coastal plain and shallow marine shelf. That's what was built there. So it's the top. The four sets, the muddy slope, that's this part, the green here, the sandy turbidites and channels, and then the bottom sets would be the floors. So imagining like a delta and geology being deposited. So this would the geology called the bottom sets down here, four sets here in green, and then the top sets here in yellow. So a lot of times you're hoping that you're going to have these top sets be charged up with hydrocarbons for a variety of reasons, especially if there's lots of hydrocarbon, shale type material and bringing oil, eventually get trapped up in here. This is a quick one on the eastern geology, the eastern North Slope. So as you move different directions on North Slope, some geology is a lot different. You'll say, well, why does Point Thompson have this overpressured zone? Over there, they have this sandstone that's just below the Hughes Shale that is overcharged and overpressured, and you don't see it on the fields. Different geology as you go. So from south to north over by Anwar, effectively, what these areas here mean there's no sequence of that geology in the south. So if you go further south from Point Thompson, you won't see any of these formations. If you start drilling down, you're not going to see, you'll see only these formations over here, like the Kingak Shale to the south, but to the north, you won't see that. So different geology depends on where you're drilling at and where it was deposited. This is a quick cross section of Liberty. And basically what they've mapped out is say, okay, on the upper part of the formation, we've got the oil, we've got some heavier oil, or we call tar here in the middle. This isn't as common in most fields, but in this area they do. And then you've got some water below it in this Kektuk formation in between these two faults. And so generally you would try to drill, either vertical or deviated wells into it or horizontal wells, trying to produce as much of it as possible. And this is the sequence showing you various sand and shale silt layers as you go down through the rocks. Sagnavir-Tok are the upper part, then you go into Ugnu, West Sac, Shale Wall, HRZ, and then you get into this Mississippian where the Kektuk formation's at, where you try to produce from. I like this one a lot. This shows from 1944, so the first oil wells drilled on the North Slope. That was up near Barrow. The Navy was doing a test well, and shows you all the number of wells, exploration. This is the number of exploration wells drilled, and then oil and gas production on days. So yeah, so this is the start of the drilling in late 1960s, drilling at Prudhoe Bay and Kuparuk, and kind of how it's gone throughout the years and decades. So a bit of a gap here in the 50s and early 60s. It started ticking back up in the mid 60s, and ever since then. And I forgot, so the colors speak to the different areas. So you have the NPRA, the North Slope, what we call the coastal plain, Anwar, the foothills, and then also in the Beaufort. And then outside that, the outer continental shelf, that's federal waters. Let's see, were they targeting? So an example here, so you'd be seeing what's called the Barrow Arch. This is where most of the oil fields are found on the North Slope. So from north to south towards the Brooks Range. You see how this stuff has been deposited, and oil like this here, the Ivashak. Imagine here, this is like the Prudhoe Bay reservoir. So this stuff is highly charged with oil and gas inside of it, very productive. So this is kind of oversized, many miles here, showing you the kind of geology as far as why these zones are so prolific. It's because they got bunched up and the hydrocarbons have been captured here effectively in a trap, and then you go out and you'll be able to produce it. Another just kind of idealization of the different the shales, focusing on the shales and where these oil originated. This shows a nice map of all the different targeted formations. So we basically focus on the Brookian top sets, the Brookian turbidites, there's the Cretaceous Rift, the Jurassic short face, and the Eldmerian, which is where all Prudhoe Bay and Endicott and all those are at. So this shows you where people were drilling from. Some of these hit multiple of these or found hydrocarbons in multiple of those areas, or where they were focusing on. So it's right now today, a lot of people are focusing on these, mostly because it's just shallower. Most of the production of North Slope is produced from less than 10,000 feet true vertical depth. Badami, we're just past 10,000 feet, and also at Endicott is a little bit deeper as well. But most oil fields vertically down from surface, less than 10,000 feet. Kind of going to well construction here, and this real quick. So The two agencies that are in charge of this, the state, the Alaska Oil and Gas Conservation Commission, they approve all permits and sundries. And then for the Bureau of Land Management, they approve their permits. On the AOGCC side, for the state, call it a permit to drill. For the feds, call it an application for a permit to drill. Quick well procedure. I'm not going to go over this long, but this is just kind of in a remote exploration well, how you start from building your ice road to setting up your rig to drilling, and how you decide, do your testing and decide if this well is prolific or not. And then in this scenario, it was determined the well's not prolific, so you plug and abandon it and move off. Examples. So here's like a vertical well example. You have your various hole sections and casings to help protect you. And then down here, if you were to, let's say, fracture this well bore, you perforate, let's say you perforated these 3 zones and fracture stimulated it. So basically fracturing, you're putting high pressure water mixed with sand or proppants, and you're trying to leave that proppant to make it a good highway for the oil and gas to move faster. In this scenario, with the horizontal well, you're perforating the wells up and down, and then your fracture stimulation will have a longer grasp of more contact with the reservoir. And just doing the basic math, you will get more production out of a horizontal well than a vertical well in every instance. So it really depends on how prolific you are, how prolific it is, how much money you want to spend. Is the formation right for it versus just having vertical wells or deviated wells? Today, most wells on the North Slope are horizontal wells. And if your formation is not competent, not strong enough, you don't fracture stimulate, you just set screens. So that way this is like a beach sand. If it has enough strength, you want to fracture stimulate it, and that proppant stays in here to have a highly permeable channels for it to come into the wellbore. Real quick on, these are a bunch of American Petroleum Institute standards for different oil and gas operations and prescriptions for tools and different things that go on there. This graphic is for like on the surface. These ones are all these API recommended practices or specifications are based on the surface. All these API specifications or recommended practices are based on the subsurface. And this is for onshore wells. This one's for offshore wells. So this would be above the water, what are different various recommended practices and specifications, and then below the water. When you're doing subsea wells and you're doing things like this where you have semi-submersibles or drill ships or floating production storage offloading facilities, and you have these subsea trees and pipelines. Very much more complicated. I'm not going to get into subsea stuff, but it is very fascinating and highly technical. Quick example of one of the original Liberty designs. So this was BP put together to drill from the satellite drilling island at Endicott using the Liberty rig to drill a long well that was over 40,000 feet. So you start from the surface and you drill down, and eventually you set several casing strings, and then eventually you end up with a 5-inch casing string at a 30-degree full angle at 40,517 feet drill, and you're trying to produce that. So these are the various hole sections inside of it that they would drill. So you start with a 26-inch hole, run 20-inch casing down to 6,200 feet. Then you drill next hole section of 18.75. You set 15-inch pipe at 15,000 feet. This is a non-standard well for North Slope. This is a very much a Gulf of Mexico type design. And right now, Hillcorp has these leases. And right now, they're not planning to do a long 40,000 foot well. They're planning to actually potentially build a gravel island over the top of this, make the wells a lot shorter. But this is very technically challenging. Right now, with the Doyon 26 rig not being available anymore after the rig toppled down last month, we no longer really have a rig that can do this on North Slope. So talking about ERD and what's called extended reach drilling, these are kind of like the window envelopes of like what's realistically available in technology to drill based off of your vertical depth of the well and then your horizontal displacement, how far. So a lot of back in, I think in the late 90s, early 2000s, Wick Farm in England set the standard as far as like the farthest reach wells that were, less than 5,000 feet TVD, but we're going out 35,000 feet departure. So this is very highly technical drilling, and the Liberty wells were even outside the envelopes. Now today, this envelope's been pushed out with current technology. So this is a very much older map, and this showed like back in the day, Milne Point, Nyack, and North Star. Nyack is pad at Prudhoe Bay, what they were trying to shoot for. The technology today has really moved this out to the right, so we can do a lot more horizontal wells.
Miles.
Yes, no, we're talking, Yeah, 7 miles, almost 7 miles out horizontal departure. I think the record right now is in the Middle East. I know there was a well that they drilled up to 50,000 feet. I think it was less than 10,000 feet TBD. So the issue with that, you can drill it. Now I spend a lot of my time trying to complete it and produce it, and that's much harder. Because trying to do intervention or other additional work in the well is very complicated. Because it's kind of like advanced plumbing. Trying to snake out any plumbing, any piping out that far, you can drill it, but then you effectively just let the well produce, and there's not much else you can do with what we call intervention. All right, the question here was, how do you create vertical fractures? Basically, you punch holes, and then you pump this proppant down, mixed with the water, and you push it, and just pressure it down, and it goes out the perforations or your frac sleeves, whatever you have, and that'll propagate into the reservoir. So it's all hydraulics. Basically how you do it.
What kind of a tool makes the vertical starter holes? To do
So if you can do a variety of different things. If you have a horizontal well, you can either case and perforate. So you have perforating guns, high explosive charges, like you do in a vertical well or horizontal or inclined well. You punch holes, and those can be done in a horizontal or a vertical sense. A lot of people now today use different what they call frac sleeves. These are sleeves that have like an OD, and so they have some mechanism that gets them to shift open, and you'll have a port. So like the ones I did recently, they have a 10 square inch port on them that are opened up. And so it basically you pump a collet or a piece of metal that comes down, lands in it, and then then you drop a ball that lands behind it, a dissolvable ball, and it will shift the sleeve open, and then that ball will dissolve over time, so that you won't have that obstruction. And when it shifts, a 10-inch port's available, and all the frac proppant goes out those ports. And it's all hydraulic. Hydraulic, you're just water and proppant with some chemicals, and it helps to just fracture the rock. It's all hydraulics, pressure. Quick examples of some wells in North Slope and the well designs. We call these well schematics. This is the fun coloring and drawing we get to do as engineers, drawing and designing things. This is at CD4, well 587, is the Alpine. CD4 is the drill site. So various different, how we kind of scale down from the surface down subsurface with different casing strings protecting different formations. The Tulivac sand is in this area. I believe it's somewhere in this area, but this well might not have been, you might not have seen the Tulivac sand as well or had any issues with it, but it would be in this area below this casing string. But you drill, you set this horizontal here, and outside you have these swell packers that help to try to divert. So when these sleeves open up, the fracture won't go, to a more, easier way. It wants to go to the point of least pressure, least stress. So generally, it's going to go out here and be forced to kind of go up into the rock and break down. There's also some geology too. So you generally want to be perpendicular to the minimum stress. That's a geologic term, but you want to be perpendicular to that. That way, it's easier to break the rock as opposed to the other direction. That comes into how your well design is and how you drill your well. Another more colorful one here. This is at Moose's 2.7 97 well. So again, another horizontal well with these frac sleeves and these outside swell packers. So basically, you'll do a sequence of pumping, the frac proppant with the fluids out each sleeve one at a time, and you'll do it sequentially. And then eventually at the end, you'll produce all this commingled together. This will probably, when it came on, was probably thousands of barrels a day. The public available information on the production of this is there. I didn't pull it up, but generally, most wells in Alaska, they're shooting for 1,000 to 5,000 barrels a day. It's a typical new well we're trying to drill. Some other examples of some quick wells on the slope, Prudhoe Bay 1141, basic well, deviated well, and you're just perforating the pipe and producing it. Formation works pretty well. This one at Moose's at Milne Point, RPAD 102 well, they put an electric submersible pump in the ground to be able to move the hydrocarbons out of the ground fast. In Prudhoe Bay, are generally using gas lift. So gas is being pumped down the backside through these various mandrels to lighten the column, and then it creates a pressure differential that allows the well to flow. And then at Milne Point, the ESP is just like a water well, but these ESPs help to draw more fluid. Generally, trying to do it where you have high fluid rate wells, water and or oil. This is an example of one of Santos's wells at Pica, the NDB, that stands for the Nisha Drill Site B, the 31 well, and they have their horizontal well here, showing a map where they drilled it. They drilled it like this. This is the plan. It generally will follow this trajectory, but they'll drill it out here. They'll drill their couple hole sections, and then they'll do a right-hand turn, and then the red signifies the area where these frac sleeves are going to be laid out. And it shows roughly, this shows just some footages around that to say what other well bores or other things are within that quarter mile or half mile radius. And this is generally what they're going to be doing. So you would see those fractures would go this direction on each side, and you'd be trying to effectively drain a reservoir. It'd be something similar to this kind of shape, roughly. Quick little thing for a drill site. So this is at Kaparik, the 3G drill site. This was when they were planning to drill the 28 well with the Doyon 142 rig and showing the footprint. So you have all these wells in what we call well rows. They're spaced out depending on the drill site age and rig design. It depends on the age of the pads and how long they've been there. But it just shows you like all these are from the wells and the piping that flows back to these manifolds for each different wells on that drill site. And then eventually it leaves the drill site and goes and commingled at the production facility. So here's an example of that well when they drilled it. Another horizontal well with the packers and the sleeves. So not every well's like this, but they're very more common up on the North Slope. A few minutes left here. We'll talk about tubulars. So a lot done stuff like this. So this is a lot of examples of the pipe we put in the ground. We call them oil field country tubular goods, OCTG. Casing or tubing. Casing is generally stuff that you leave in the ground. Cement. Tubing is where you usually produce from. So tubing is the dedicated pipe that will be where all the oil and gas flows up through. This example of just some information on drill pipe. So the drill pipe we use to drill the ground, to drill the wells. You'll have the different, what's the OD, what's the wall thickness, what's its tensile strength in pounds, how much can it lift, what's its pressure it can absorb, for burst and also for collapse, and various other different information about the drill pipe, makeup, torques, things of that nature you need to know to how to handle that pipe and make sure that you have the proper strength so it can drill to the proper depths and for the proper hole sizes. Examples of different threads we use. TXP, this is a buttress thread. BTC stands for buttress thread and coupled. So you have a coupling that goes with this, with the male end threads, and then you have the coupling is the female threads that kind of come together. Some pipe doesn't have a coupling. It's just made up together where the threads are matched together. This would be called a flush joint pipe. An example of this would be Hydro 511. There's other pipe that has two steps where there's two different threads like that. This would be CS Hydro, and then some of the strongest pipe we deal with today is Hydro 563. It's a wedge shape, very strong. So we deal with that. Measure the outside diameter, inner diameter, the coupling diameter. You can also have special clearance couplings if you need to have that for some reason. You can kind of shave it down. We measure the wall thickness, and then we'll move on to some other information on this. So this is just some information sheets we have for these different pipe. And we use that to make a determination, make sure the pipe's strong enough for what we want to use it for. There's all kinds of other different pipe groups. BAM's very popular. High torque pipe here. BAM top is just a premium connection for standard production wells. And I'm going to try to wrap up here on well control. So I got a few minutes here left. So well control. So this is about making sure you don't have blowouts and that you properly maintain the wells. You don't want to end up like Repsol did with the Kugrip 2 well. Back in 2012, that spill cleanup cost $100 million to clean that up. That was in the middle of February in 2012 when they had the Tulaxan blew out on them. So we do risk assessments. We talk about the different risks of these different events and the different hole sections and what our mitigation strategies are. And we have contingency plans. And then different well control schools. This is an example of various well control schools that are available out there that can be taught. I've done this one, I've done that one, I've done that one, I've done that one. So generally for most engineers, you get recertified every 2 years in well control. And then all of the field people, rig hands, they're gonna be there involved in shutting the wells. They will also have to do their well control training every 2 years. This is an example of just talking about the basic hazards you might have. If you have gas hydrates in the well, make sure you have proper hole cleaning, anti-collision, you don't collide into other well bore. So you want to make sure you don't drill into it. H2S gas, if you have any H2S, that's generally on the production side, you have to worry about that. And this is just an idealized of showing this. I think this is that Milne point, showing you the different issues you have to deal with when you're drilling. Issues with sands and clays and other parts you have to deal with. And this just goes into more information you can kind of look at later on as far as different hole sections, different wells. You kind of identify them and then mitigate them. More hazards to identify and mitigate. And this is part of the good stuff, making sure you're doing it properly. So when you have your blowout contingency plan, you have to file that with the Department of Environmental Conservation. This just says, in an event of a well control incident, what you're going to do. Different levels. It means like if you have small blowout versus a medium versus a very large, blowout that's causing lots of problems, and how you're going to respond to it. So we'll finalize here on fracture stimulation on proppants. So you have usually natural sand, you have resin coated sand, and you have ceramic proppants. These are the basic 3 types of fracture proppants you will use in the ground. So some examples of this, they'll be, if they're manufactured, they'll be of various different sizes. So generally, comparatively, sand doesn't have as much conductivity or permeability as opposed to resin coated versus ceramic. And in this example, Cryptosphere is just one brand of frac proppant that's available through Carbo Ceramics. So generally, you will look at to say what's the fluid permeability. We measure it in millidarcies or darcies, and so shale will be very low permeability down to the nanodarcy, and as high as in multiple darcies. That's a very good beachy type sand. And then you'll have your different fracture closure strengths based on what the proppants, what they can handle as far as the rocks. And you'll look at to say, are we in an unconventional shale? We're trying to get oil out of these tight rocks. Is there tight gas? This is just showing bricks to say it's very tight gas, or conventional sandstones used just to help stimulate and increase the rate of production. So typical layout and well design. I'll show you some more, but with the pump trucks and all the manifolds, and what you're trying to do and trying to fracture stimulate the subsurface ground. This example in lower 48, you've got dozens of pump trucks all around there trying to get enough rate and pressure. Sometimes it could be as much as 100 barrels a minute of pumping down the wells. Generally in Alaska, you're usually about 30 barrels a minute, but they're just trying to get all the water and all the sand and all that mixed together into these pump trucks to have enough hydraulic horsepower to pump at the high rates and the flow rates they want to pump down the well. So basically you have all the sand storage here, you blend it here with your chemicals, make sure it has the right properties you want, and then you have your water mixed with it, and then these pump trucks pumping it down the well. The whole sea of pipes and pipeline of pipes all together coming together to orchestrate this. So this is not typically how it's done in Alaska, but this is just showing you some extreme examples in the lower 48. So this was an example in Alaska as far as the equipment that was used on site from one of the permitted drills. You've got your blenders, you've got your frac pumps, you've got your missile. That's a different thing. That's like a truck to help you. Frac cat, this is how we use for your data acquisition. You've got your sand sheets where you store your sand at. Frac tanks hold your fluids. The conveyor moves the sand from the sand sheet over, get it all blended together. And yeah, it's a whole orchestrated group of equipment and very specialized. This is an example of a rig up. So if you have this tree where our different pipe manifolds, you put this additional tree on top to be able to drop your collets or your balls or whatever you're going to do to be able to fracture stimulate. And all this iron is usually rated for 10,000 to 15 or 20,000 PSI. You have all these different high pressure lines that come together to then go into, mix together to go into the wellbore to make all this happen. Example to just a visual. So if you have rounded proppants all the same size, you'll see the permeability in that versus if you have poorly sorted angular rock, you're going to have a lot less permeability in that. So this is why they do engineered ceramics and proppants to try to maximize effectively the highway for the oil and gas to move quickly. So quick example of some resin coated proppants and some uncoated proppants. Just visually, we'll borrow that. And then on this one, we're talking about the proppant pumping schedules and the pressures and the rates of what we do. So in the quick summary of what you've done in a frac job, you'll say how much of your fluid have you used, and then how much of your sand. So in this one, they used 1.6 million pounds of Wanley 2040. That's the sieve size. And yeah, and then they'll go through the different stages of the different sleeves, usually of where they pumped and all the different pressures they saw and the various different factors. So that was this Campari 3G 28 well that ConocoPhillips completed, and this is in 2019. So this is all publicly available data on the website and AOGCC. So nothing special about this, but this was done on this job. This is an example from Pika, from Santos, from a recent well that they've done. Talking about the different stages and all the different proppants they've done. So this is all publicly available information. Well, you know, you'll get the stages. So they did 31 stages in this well. And that's getting more and more. We're getting able to do more and more stages per well. And it all depends on the geology and how long you want to drill it. And pressures. So pumping and pressures that are 5,000 to 6,000 pounds. And you're trusting your lines to make sure you're safe, 9,200 pounds. Your maximum pressure you're anticipating to work at is 8,800 pounds. So you make sure you test above what you're going to think you're going to get to. And then you have your different trips. So if you do exceed, so this one at 8,500, it would open up and trip it and cause a pressure dump. And the pressure at the pressure trip for the pump is 7,800 pounds. So if your pumps start getting to 7,800 pounds, it's going to trip and shut the pump off and not allow you to go to that side. So it's managing everything and making sure you're gonna properly do the proper stages of the job and how you're gonna get it. And basically you can look at real simply what your sand pressures and what your gradients are for these zones. So the pressures these break down at are usually in these areas, PSI per foot. You can calculate based off the depth down to there. Does fracking produce more oil or just get it out faster? Pretty much the answer to that is both. If you move oil out faster, theoretically you can produce more from that same reservoir. Because if you don't produce it out, a lot of oil can get trapped or left in the ground if you don't have pressure support or it doesn't come out of the ground. But generally, you could produce that well, you didn't fracture stimulate it, but it could take you 20 to 30 or 40, 50 years to produce the same amount of volume. By that time, it may not be economical for your facility to do exist. So generally, fracking is a rate acceleration thing, but then some formations require to be fracked for it to be. If you drilled a well and it's only going to make 50 barrels a day, you're not going to want to spend 20, $30 million drilling that. But if you can produce it with fracture stimulation, it's making 4,000 or 5,000 barrels a day. You'll do that every day because it's going to come out a lot faster. So generally, fracture stimulation helps rate acceleration, but it also helps generally to boost your production. So for those the sciencey chemistry side, this is a chemical list. So every well since like after 2010, sometime after that, you have to do a chemical disclosure of all the chemicals that are in your frac water, and these are the various different things and different percentages of what you're dealing with. So it has even the CAS numbers, so you can kind of look back at that. Generally, though, none of this water in Alaska is going back into our water systems, and it's not near anybody's public water zones because we're not drilling near all that. This stays in the oil and gas reservoirs. It gets mixed in with the other waters down there. Nobody's drinking water involved. And generally, you just don't want this stuff spilled at surface into the oceans or into the rivers and the lakes. So that is the end of that. Any other questions from the group here?
Can you tell us what's going on at Smith Bay these days?
Smith Bay. So there's a group called Narwhal, and they're hoping to do exploration wells out there. Personal opinion, I give it less than 50% chance they're actually going to do anything.
Didn't somebody claim to find a lot of oil?
Correct. No, there was a claim many years ago. There's a lot of oil right there. Claims of oil are worth the paper they're printed on, effectively. There's a highly likely chance that there is oil there, but it depends on how much and what horizons and how long it would take you to develop it. If the oil is in little small volumes in little different areas there, it's going to be harder to get versus if it's in a bigger pool, like a Prudhoe Bay size pool, or is it a smaller pool, like a small turbidites that we deal with. It all depends on that. There has been some wells drilled around that area. The issue will be, the proof will be in the pudding, will they actually want to actually drill an actual exploration well and production test it. So that's generally where people get the proof in the pudding. You could drill a well today and get your geology, say, it looks great, it's got all the geology, it's got all the hydrocarbons. If you don't flow test it, generally people will not trust you and you won't actually have any proof that that well can actually generate the hydrocarbons. And that With just one point though, in a whole map, that only guarantees that general area there. That does not guarantee miles away that your field has production horizons that are gonna make it in. Generally, most fields in Alaska, you're not going for one sand. It's usually, there's multiple sand packages, and you will high grade, say, generally, let's produce from the ones that are bigger and produce faster, and then as those wells deplete, we can sidetrack and develop the other horizons as we want to go, or just perforate the existing wells. That's why Prudhoe Bay has been so prolific, in other fields. Like I dealt with it in Cook Inlet and Milne Point, the North Slope, is that with this zone, water's out or just no more hydrocarbons, you move up in the wellbore, hopefully there's no hydrocarbon zone to produce from. Generally, the stuff like the Ugnu, that the heavy oils in the North Slope, it's just harder to move. Why the Nunishuk stuff that people drilled through for years and decades, but never produced, because it's harder to produce it than it is the conventional Kuparuk sandstone, the Ivashak, and the Jurassic and Alpine. The Nunishuk, they solved it by drilling long enough wells and having the fracture technology today in modern times to be able to be more cost effective at doing that. You could have done it back in the 90s, but it wouldn't have been as cost effective. And you couldn't drill long and this complex wells to get what they have at Nunishuk today, 20, 30 years ago. It's not like complete rocket science, but there's just more technology and stuff that we're learning today. Other questions? Yeah.
So original Prudhoe Bay, they didn't need horizontal wells.
No.
They didn't have the technology probably back then.
Horizontal technology in the late 60s was very mature. Only been done probably a few handful of times. And the issue is you could do it, but you couldn't really complete it or know how to deal with it. And the permeability is so high and the pressures are so good, you don't need horizontal wells at Prudhoe Bay.
So to keep production up, they do need them now.
Then you do what?
They need horizontal wells now to keep production up.
Not necessarily, but it's more convenient. What they do today at Prudhoe Bay is you drill small little horizontal wells with coiled tubing. Generally, they're low cost, and you can go and access those areas. And basically, at Prudhoe Bay, it's a pressure maintenance game. If you maintain the gas cap and maintain the water flood, you can keep getting that oil to keep moving out. The oil is very good quality oil. The permeability is very high. It's just a matter of making sure you effectively sweep the areas and don't have too much gas and water. That's most of what Prudhoe Bay's limitations are today. They've got so much gas and water they're handling, it's their facility for bottlenecked. And you're trying to get the little pockets of unswept oil all across the field. It's huge. There's dozens and dozens and dozens of drill sites. There's thousands of wellbores at Prudhoe Bay. Very complex.
How many wells are producing and connected?
At Prudhoe Bay?
Yeah, just roughly like.
Producing, I would guess at least over 500.
Wow.
At least. Yeah. And then you have all your injectors. You got to maintain all your injectors, water injectors, gas injectors. Yeah,
So if they bring gas down, is that gas gonna have to reconnect all that sources?
If they want to produce the gas, they talked about 3.5 billion cubic feet a day down the pipeline when the LNG is fully operational, they will have to find additional gas in North Slope. Yes. Right now, the main gas at Prudhoe Bay and Point Thompson, the 35 TCF they've talked about. But once you start producing that gas in large volumes, you will need to start drilling for additional gas.
And also to collect it, they'll have to put the lines in, correct? There are gas.
No, they'll need to put in a dedicated gas compression facility that will also clean the gas, remove all the impurities they don't want to have in there. And then also you'll have to bottleneck it because they have a central gas facility at Prudhoe Bay, and that facility handles about 9 billion cubic feet a day of gas. So it takes all the gas from the field, conditions it, strips out all the water and the other impurities, and repressurizes that back out to the field for fuel gas, gas lift, gas reinjection, other issues they need for gas. So that 9 billion cubic feet a day is at -20 in the middle of winter on the optimal day. -20 is the optimal temperature for their gas compressors.
Because they're always worried about running out of oil into the pipeline. Is that a real concern? You should answer good questions.
Yeah, right now, the Trans-Alaska Pipeline, I believe their minimum flow right now would be like around 300,000 barrels a day. We're doing just under 500,000 barrels a day, but they can sustain, it's the drag forces. So right now, everything's hinged on Pump Station 9. That's their choke point of how they operate the pipeline.
Is that up north or down south?
Pump Station 9 is south of Fairbanks.
Okay.
Yeah. is the bending radius of the drill pipe? Good question. Bigger drill pipe, less bending radius, smaller drill pipe, more bending radius. 5-inch drill pipe, we can drill dog legs that are 10-degree dog legs, so 10 degrees per 100 foot easily. Pipe is actually pretty bendable, actually. It actually can do pretty good. Coil tubing, you can do just like 30-degree bends with no problems. But most drill pipe, we're trying to usually not get dog legs that are over 5 degrees, 5 to 10 degrees at most. But it's fairly flexible. Smaller ODs are more flexible than the bigger ODs.
So you're going like this and that, because I was surprised in those photos or the table, how small diameter it was.
Yes.
What's typical
It's
average or?
typical, so at the bottom of the well, most hole size at the bottom are either 8.5-inch OD or 6-inch OD.
Okay.
The whole size. And then the typical North Slope well, these are almost all 4.5-inch OD pipe.
Really?
That's the typical. In the Lower 48 Permian, that you do 5.5, but we are mostly, the standard bread and butter for North Slope is 4.5 OD pipe. That's the standard, and you'll see it in all the different wells
And
that.
that's because of the pressures, you can get the oil out even in that small diameter.
Yes, no, those diameters, the biggest wells in the slope right now, the biggest well ever at Prudhoe Bay made like 22,000 barrels a day back on JPAD back in the day, in the late 60s or 70s. Today, like I said, we're hoping for 1 to 5,000 on the high end, 10,000. You can move 10,000 barrels of fluid a day through 4-inch pipe, 4.5-inch pipe, relatively easily. The issue with the hydraulic forces, if you have a lot of water or gas, that'll cause extra friction.
And that natural pressure, or it has to have the facilities on the bottom?
You start off drilling with natural pressure, but if you want to maintain the rate, you want to supply additional pressure through water injection. Otherwise, we just call it primary depletion. If you have no pressure support, the reservoir just deplete itself. All right, question. Can you clarify what is the rightmost column header for the chemical news? Let's see. Oh, that was the percentage. That was the concentration. That should have been the concentration typical of that fracture fluid that they had. So that's what they came up with as far as the percentages. All right, other question. A few years back, Oklahoma started having earthquakes that were tied to putting fluid back in the ground. Is this a risk for Alaska? So those earthquakes in Oklahoma and Texas, they are related mostly to the water reinjection. So when you produce a lot of oil and gas, and you have the water, you have excess water. They're dedicated. They call them saltwater disposal wells, but it's the brine. It's the oil filled water. They reinject that into water disposal wells. And generally, with those earthquakes, they're tying them into lubricating faults. So if you're reinjecting water into an area and you overpressure that area and you lubricate a fault, effectively you overpressure and give it pressure, you're going to cause the ground to shift. And that's what's causing those earthquakes. Here in Alaska, seismically, where we drill currently is pretty much a dead zone on the North Slope. In Cook Inlet, obviously, it's very active. Right now, thinking of all the different fields, the AOGCC is very good at regulating to make sure that we are not over-injecting too high in certain fields. They want to maintain a balance. So if you, let's say, typical gradient in the ground, water gradient down to surface at 8.3 pounds per gallon. If you got your reservoir up to like 12 pounds per gallon, that's overpressured. But is that really going to break anything or cause problems? Not necessarily. Generally, you're not allowed to just dispose of water in areas and just kind of just go whole hog. You have pressure limitations and volume limitations on most of your disposal wells. So it's a much lower risk in Alaska because we're not drilling and producing with these high rate volumes near production or near population centers. And like I said, on the North Slope, you're not near a lot of seismically active areas. There is some seismicity over near south of Anwar, but up the rest of the North Slope is very much a dead zone, and there's not been any shown to any kind of correlation between lubricating faults with people re-injecting things. It hasn't been a thing up there. And I think it's basically the geology and how we kind of manage everything. Very much, our volumes are a lot less volumes than they deal with injection down in the lower 48. They inject a large volumes. They make a lot more oil and gas and water than us. So that's part of what the reason for that is. Any other questions?
What do you think the biggest issues with Doyon 26 being down will be?
All the rig availability. So I already know with that, there's one less rig that can drill the North Slope. So ConocoPhillips had that rig pretty much dedicated to them, and now they still want to drill the same amount of wells they want to drill. And right now, they were not planning to actually use that rig, to my understanding, to use that rig with full capabilities. So other rigs on the slope are available to drill what it was going to plan to drill. And so it just means one less rigs being available on the slope. So when oil prices start ticking up here, and we're anticipating they will, and exploration season kicks off next year, we're anticipating there'll be of the available rigs, most of them will probably be taken up. And when I say available rigs, there's plenty of rigs. If you go to Dead Horse, you want to look at a bunch of lawn darts sitting up there. There's a bunch of irons been sitting up there, some of it 20, 30, 40 years. And if you want to reactivate those rigs, I would guess you need to spend 5, 10, maybe $15 million just to get the rig ready and available. So unless you want to cop that money up front, you wouldn't have an incentive to use that. You want to use quote unquote a warm rig or a rig that has not been in disrepair. So versus we have on the slope, we have Doyon, we have Nordic, and we have Neighbors. Neighbors recently bought Parker, so the 2 Parker rigs are now part of Neighbors, and that's effectively the majority of our drilling operations, or those 3 main. And generally, we usually operate around 10 rigs are drilling up North Slope at any time, and that's usually, I'm not sure they're actually incorporating the coiled tubing rigs, CDR2 and CDR3, and then people also forget about the workover rigs up there. Those dedicated workover rigs like the ASR rig that Hilcorp owns. They used to have a Thunderbird rig with a dedicated rig from the lower 48, but there's quite a bit of rig activity up there. It's not anything kind of record breaking, but we anticipate there could be a big increase in that. Any insight as to why the Doyon rig fell over? Yes. So that rig fell over right next to K-Pad out at Alpine. It's the road that goes down, connects Nuiqsut into the Alpine road system. There's a pad called K-Pad, it's a storage pad. They have a camp, mud plant, another various storage right there. They were moving the rig. It was the temperatures were above freezing. I believe it was about 34 degrees up there, and the road got soft for some reason, or there was a mechanical breakdown on the rig itself. So the rig itself has some moving system that moves. Generally, those move less than 2 miles an hour, probably about a mile to a mile and a half an hour. So the rig stopped. Enough heat happened. They're on a gravel road, but there's a layer of snow above that and ice on top of that. The rig eventually sunk into that for some reason, and it was tipping. My understanding, it was tipping for several hours, and eventually it tipped enough over where the weight of it toppled the derrick over. So right now, all of the rest of the rig that didn't topple over, the other support modules are currently in Dead Horse. You can actually go on the FAA webcam and actually see them sitting there, right next to the Dead Horse Aviation Center. They're going to scrap the rig, as far as my understanding with Doyon, at least that derrick and the substructure, the subbase of the rig. Rebuilding that, my guess, I think at least plus minus 1 year. That was built in Nisku outside of Edmonton. So yeah, it's going to be interesting to find out what's going to happen with that, because that was the largest land rig in North America. It had the best capability to drill the deepest wells. So I guess we've had the Liberty rig too, which never actually drilled a well. Now Doyon 26. So we've had 2 of the biggest rigs go down there, but hopefully there'll be some lessons learned as far as moving rigs, because I was involved last year moving Doyon 19 out of Adami, and you always have the same concern. If you get onto some road section where it tips over, you don't want it tipping over onto pipelines or onto people or anything of that nature, destroying wildlife. There'll be definitely some interesting finds on that. I think right now it's all stuck with the lawyers and the insurance agencies and that kind of stuff. So probably not a lot of information is going to come out right now, but we'll have some more findings in the future.
I did want to ask about that. So you have this big area with different pieces, different owners. How do they coordinate where the pipelines are, where the roads are, where the paths are? Does everybody get along and talk amongst each other? Or is there someone in charge of the big picture? Just
There's discussions. Recently, Santos and ConocoPhillips were in lawsuits because Santos wanted to use the same road system there at Oparic. Conoco didn't want them using it, so then you effectively go to arbitration. You go to the parents, or the state of Alaska, or other federal regulators, and try to actually have agreements there. A lot of it's regulated
Permitted.
and permitted with the state, the feds, local and North Slope Borough, local agencies. The pipelines are, if you're a designated common carrier, you have to allow access to other people producing oil and gas into it. But there can be limitations on the volumes in the pipeline, like the Kaparic pipeline. It has Kaparic, Alpine, Millie Point, Nakiatug, Ugarik, Mustang, all these fields are trying to produce into it. And some pipelines, it depends on what the OD of it is, have a limitation on its.
So somebody's maintaining a big map and they know where all this stuff is and where there might be.
Correct, yes, no, there's people that know where all this stuff's going, they divvy up the royalties, they know, there's a lot of different people you don't see or hear about on a daily basis, like my job, I work at Glacier Oil and Gas, one of my primary jobs to know of the wells that are producing in our different fields, why are they producing what they're producing, are my injectors doing what they're doing, and on a regular day-to-day basis, other people don't know like what's going on, I see the data and I have to crunch it to kind of say, okay, is this healthy? Is this not healthy? Is there something you do to improve it? Is it everything, copacetic? And you try to utilize that, then think about what you can do to improve. Most of what you're trying to do is trying to improve the rate of oil production, minimize gaps in water as much as possible, but recognizing right now we will eventually have a gas pipeline that will be very much a big, incentive to produce gas down the pipeline. And those have been in place pretty much since the Gubic wells were drilled by the Navy. So the first gas well designed off the slope, the first oil pipeline off the slope, was actually thought of by the Navy. A 4-inch line from Umiat down to Fairbanks and a 4-inch gas line from Gubic down to Fairbanks. So those were the original gas lines off the North Slope when they were drilling up there, and they discovered oil and gas on the North Slope in NPR4 at the time, back in the late 40s, early 50s.
So my last question, isn't there an area of the country that are the experts, in other words, they design the different pipe, they supply it, or is it spread across the country down below? The technology, where they get the pipe, the ideas for different joints, all the stuff to do, the fracture material, whatever. Is it in one area of the country, is it all
No, it's spread out globally.
over? Okay.
There's global groups that, I would say oil and gas is pretty much a global commodity.
Thank you.
And in 2004, when I worked for the Bureau of Land Management, put together an energy kiosk at the Campbell Creek Science Center. At that time, in 2004, the world was making 80 million barrels a day. Today, we're close to 105 million barrels a day. So we don't have peak oil. That's kind of a fake news thing. It really depends on the incentives. If you look at the modern politics, what's going on, there's a lot of oil related to that. The country of Guyana in 2015 was making 0 barrels of oil. 2025, they're making 900,000 barrels of oil, almost double what we make. In 10 years, Guyana went from 0 to 900,000. So the opportunities are out there. This is all offshore. This is offshore, not onshore type stuff. The technology is there. It's all related to politics, political risk, equipment availability, countries availability. Do the people want to do it? Who's going to put up the money? There's lots of different transnational corporations, like Repsol is a Spanish national oil company, Total is France's, Eni is Italy's, Exxon and Conoco, Hilcorp, these are American-based companies. And it all really depends on who gets approval to do what, who has money to do what. We'll see where Venezuela goes after all the stuff that's going on there. There's been a lot of production. Right now, Saudi Arabia said, we're going to increase our production. We're anticipating Iran's going to have their production go down. Strait of Hormuz, other politics go along with that. The tankers, moving tankers around the globe. It's like watching, playing a video game of where you move oil, sanctioned oil versus non-sanctioned oil. The pipelines, how do you determine that? A lot of it, there are specifications like global or SPE, ASTM, API specifications for what is good pipe, what's the right kind of thing, and we have different standards. So most of that, right now, the gas pipeline, it's a 42-inch pipeline, and that's all built to spec. They already have the specs. The pipe, I've heard the pipe's already on the ground, already ready to go, from the manufacturer. And most of the pipe you would get would be from South Korea, Japan, those parts of Southeast Asia. Those are the people that make the largest volumes of pipe for what we utilize here in North America. And then we got Canada. Canada produces over 4 million barrels a day. It all comes into the United States from the oil sands. So there's a lot of geopolitics, and you have to kind of know where oil moves, where it comes from.
Sideline. And do you get involved in decisions to produce or not? your job?
Yeah.
Okay,
I-
that'd be tough.
Yeah, I've been sitting on projects right now where we say, hey, we wanna drill this well, and it's gonna cost this amount of money. So then you gotta come up with the money, and then the risk, because with the well we drilled a year and a half ago, we said we were gonna drill it for this amount of money and do it this amount of time and get this amount of production, and those didn't happen. And that, there's always risk in anything you do. None of this is a slam dunk. This isn't sort of like, oh, they secretly know how to drill this, they always get it right. Like, no, this is human risk, human factor. People want to minimize their risk, but they want to take chances, because in the oil field, sometimes you take huge risks, you'll get huge rewards. Just look at Guyana. I mean, Exxon took a huge risk with their partners, they drilled these wells, and now they're making 900,000 barrels a day. Like, who saw that coming? I didn't, so, and why? Why is Guyana producing what it produces? Same thing, like, why is Iraq producing so much oil? Why does Saudi Arabia produce so much oil? There's a variety of factors that go into how you do this. And then Alaska, why do we not? Basically, if you want to say for Alaska, the production of Alaska is almost directly incorporated how many wells you're drilling. And so, on average, if you're drilling enough wells, you will have enough production, because your production is usually always declining. So if you have let's say there's like 2,000 wells in Alaska producing. Right now, if you stay static and you don't do anything else, that production is going to decline slowly. So you need to add new wells. That's why Pikka with Santos is very important. Willow would be very important.
So it's very odd to take an existing well and use that at a deeper or higher level. You mentioned that.
No, we do that on a
Do that,
regular
but
basis.
it's not really,
We call that intervention. They do that all the time.
but it's not gonna really affect the drop production.
It will help to sustain and stem the decline. That's basically true. Generally, yeah, you're not going to go gangbusters. Sometimes it's happened. A few workers I've been involved with, all of a sudden the well was making this amount, and then you did a work over in another horizon, and it went way up more than you expected. But right now, the only way you're going to get out of a decline is by drilling. You need new wells.
You talked about all the other basins in Alaska. Are any of them under serious contention to start a new basin somewhere?
No.
They don't have the oil, or
They don't have the politics. No.
it's
Politics.
politics. Okay.
The drive. People are too afraid to branch out. That's why Anwar is a political football.
Yeah.
I was told when I worked at the Bureau of Land Management over 20 years ago, I said, the guy's like, Stan, you'll never see Anwar opened up. Now it's technically opened up, but as soon as the leases were given, in 2 weeks, they were already squashed. And the three groups that bought the leases got blocked by the Biden administration. Now, the Trump administration has reopened those up theoretically, but there's still the lawsuits going on, because these people spent money to buy the leases. These were all small Alaska-based companies that bought the leases. And so politics plays a big part, because going to new basins is really risky. People don't want the risk. That's it. They want to minimize the risk, because people don't sit in their beds right now thinking, how many wells they drill in Prudhoe Bay today? That's kind of scary. Nobody's thinking of that. They don't think of that risk.
Okay.
But if we said, hey, I'm going to drill offshore in the Beaufort Sea, they're going to, whoa, what could happen out there?
I was thinking more of other completely different regions where you showed basins.
Yeah.
Same thing. It's just, it's too expensive even to get it going.
Hillcorp, like I showed, they're drilling the Yukon Flats. The
Oh.
issue is, once you find the oil, now you've got to ship the oil.
Right.
You've got to build a facility. You got to make sure the roads available. So most oil and gas, the reason why it's hard to bring in new fields is because of all the upfront costs and the time. The average time right now from your exploration, we can drill and discovering oil, to when that's actually produced on a basis, is over 15 years.
So there could be a lot of oil there, we just don't know.
Correct. And we don't even drill, like I said, much past 10,000 feet. We could be drilling to 20,000 feet, and all of a sudden like, hey, there's this well that makes like 30,000 barrels a day, but we didn't know.
Yeah.
Upgraded laser technology, seismic technology, eventually we'll be able to do other things in the future. And then, maybe hydrocarbons won't be as important in the future compared to other energy, things that you could use. So in the interim, the thing is, you want to diversify your energy. Kind of just not talking about this food, but low cost energy is generally the best energy, as long as it doesn't have other ramifications with it. Right? Because you don't want to just do stuff willy-nilly. But oil and gas here in Alaska, it's going to be here for a long time. Like I said, when the gas pipeline goes in, you're gonna be drilling gas wells before that even goes into place. Because even when they start piping gas down to Fairbanks and Anchorage, you need to replace that gas, because if you don't replace that gas in Prudhoe Bay and Point Thompson, you're gonna leave liquid hydrocarbons behind. So you need dedicated gas wells producing in all parts of areas, so you have enough molecules for your gas lift, for your gas reinjection, for fuel gas. Gas is very important. We import gas at Badami from Endicott to supply our field, because we don't have enough gas for our gas turbines. So if we had enough gas, we could be cycling it, doing other projects, but we don't have enough gas. Other fields, Papara doesn't have enough gas. They usually import gas. So that way they have enough. Yeah, it's all logistics. Everything's logistics. Who has it? Who wants to share? Who doesn't? Who wants to share a rig? Who wants to share costs? It's all logistics. There's politics, timing, finances. Do the companies have the finances to do it? That's really a lot of big part. And then oil prices. Right now, oil prices ticked up like 2%, almost 3% today. Does that change people's numbers? Generally, no, because most companies are always looking long term. They're hedging their bets and their risk, and they'll do it that way.
I'm sorry, thank you.
On these barrel per day figures you cite,
Yeah.
are the petroleum industries barrel size standardized with other industries?
Yes, yeah, it's ubiquitous across the globe. Yeah,
What,
42 gallons is a barrel.
42 even?
42 even. Yeah.
That's US gallons.
Yes, 42 US gallons is a barrel. That's in other areas you'll measure oil in cubic meters. So that's a little more complicated. Think of almost like a cubic yard in a sense of oil, or they do it in tons. They'll do it in tons of oil. And that's always confusing me when I hear like in Russia, they made this amount of tons of oil. I'm like,
Metric ton?
it is a long ton, a metric ton, a short ton, and even gas. You measure gas. Gas for like the LNG. They measure it in million tons per annum. So we want to ship out 20 MTPA. And you say, well, what's 20 MTPA? Once you do the calculation, the back calculates to roughly 3.5 billion cubic feet per day. Is the rough calculation. I mean, in my mind, it might be like 3.25, 3 point somewhere around there, but that's a lot of gas. Right now we're selling zero gas in the North Slope. In Cook Inlet, think of the high end, we use like 300 million cubic feet on the coldest days. Like a day like this, the whole network, I think it's probably just a little bit over 200 million cubic feet. So 3.5 billion cubic feet is over 10 times what Anchorage uses on the coldest day. Imagine that being sold and shipped out. And global prices for LNG, plus or minus $12 per MCF. It all depends on who you're selling to. We've got tentative agreements with Taiwan, Japan, South Korea, Vietnam, Thailand. So, but the ultimate goal is to get to 20 million tons to sell, to make it economic, to compete with Qatar and the other LNG exporters, Australia. Kitimat in Canada, they're on production right now. They're actually producing LNG up just north of Vancouver. They beat us to LNG exports. The Canadians did, yeah.
Wow.
At Kitimat.
And that's the field right there, or is it coming from the?
No, it's coming from the field to the east. Yeah.
Okay, thank you.
Kitimat is the port, exit port.
Yeah, we've gone a little over. I was gonna say, yeah, sorry. Super interesting topic. We want to, thank you so much for getting it. There's a survey too, like, make sure to fill it out. That is the password.
You.
Yeah.
Fine.
Just got mine.
I'm a local.
Yeah.
If you do my daily stuff.